Hello friends, I am Himanshu Mishra in front of you for this our physics session. So let's start our class. So in our previous session, we have discussed various types of motions in which we have discussed periodic motion, oscillatory motion. After that, we have discussed some basic terms which was used in the study of simple harmonic motion. Now we are going to study the displacement, velocity and acceleration in simple harmonic motion. So first of all, we are going to start with displacement in S.H.M, simple harmonic motion. See, let us assume an object which is moving in a circle. So basically that path is also be, that kind of motion will also be simple harmonic motion. So we have assumed a particle of mass small m start its motion from, this is its mean position, and after time t the object reached at point A, let us assume, or let's assume point P, that will be much better for us. The angle covered was theta. Now we are going to write, let this object is moving with angular velocity omega, time taken is t. So what is the angular displacement? So angular displacement theta can be written as omega into t. If you don't understand how this come out, then we can write it as velocity is equals to displacement upon time. So displacement is theta, time is t, and velocity is omega. So from this equation we can write theta is equals to omega into t. Okay. चलिए आगे चलते हैं इससे. Now the coordinates of point P is x comma y, then what will be the value of x here? See, the radius of circle is capital A, so the value of x will be, x is equals to A cos theta, and this will be A sin theta. So x is equals to A cos theta and y is equals to A sin theta. Is this okay? Now substitute the value theta here. So the displacement equation of simple harmonic motion, displacement equation of S.H.M will be y is equals to A sin omega t, as well as we can write x is equals to A cos omega t. I hope you guys are familiar with this. So this will be the equation of displacement of simple harmonic motion. If there is an initial phase phi, then equation will become y is equals to A sin omega t plus phi. Okay. Now let's move forward. We are going to write now the velocity of particle in S.H.M. See, what do you mean by velocity? So we can write velocity v is equals to dy by dt. So basically this is the first differential of y with respect to t. Now substitute the value of y here. So v is equals to d by dt of a sine omega t. I didn't assume that initial phase. If you will consider initial phase, then phi will also be added to omega t. Now differentiate this. So v is equals to a is constant, or basically a is amplitude, sine omega t. The differentiation of sine is cos omega t. Now we will differentiate omega into t. See, we are going to differentiate with respect to t. So omega into t will be omega. Is this okay? So this is the general equation of velocity. Now you can rewrite it in the terms of displacement as well. Let us check. V is equals to a omega cos omega t. Now you all know there is one formula, cos theta is equals to under root 1 minus sine square theta. So substitute the value here. So V is equals to a omega under root 1 minus sine square omega t. Is this okay? Now if we multiply this a inside this square root, then the value v is equals to omega under root a square minus a square sine square omega t. Is this okay? गौर से देखिए, a square sine square omega t is looking like displacement y square. So can we rewrite it as v is equals to omega under root a square minus y square. So this is the equation of velocity. This is equation of velocity in terms of displacement. Is this okay? And this is the equation of velocity in time t. So equation of velocity in terms of time t. Is this okay? Now we will discuss further the value of v is equals to omega under root a square minus y square. Now square this term. So v square is equals to omega square multiply with a square minus y square. Now cross multiply the term omega square. So we can rewrite it as v square upon omega square is equals to a square minus y square. Is this okay? Now transfer this y square to left hand side. So this equation will become v square upon omega square plus y square is equals to a square. And now we can cross multiply this a square. So the equation will become v square upon omega square into a square plus y square upon a square is equals to 1. Is this okay? I think this equation looks like x square upon a square plus y square upon b square is equals to 1. This equation is the equation of ellipse. So the relation of velocity with displacement is equation of ellipse. Can we draw this ellipse? So We can draw the ellipse here as well. See, this is x-axis, which is written as velocity axis v, and this is y-axis or the displacement axis. Now, the graph will somewhere look like this. So, this is the graph between displacement and velocity. Is this okay? I hope you guys are doing good with this. Now, tell me what is the value of V here. V is equals to A omega cos omega t. Now, we are going to write the extreme values of velocity. Extreme values of velocity. So, the equation of velocity was written as V is equals to A omega cos omega t. Now tell me what is the maximum value of cos theta. The maximum value of cos theta is 1, or the extreme value of cos theta are plus minus 1. So if we rewrite the extreme values of cos theta are plus minus 1. So the V max can be written as plus minus A into omega multiplied by 1. So basically the maximum velocity can be written as plus minus A omega. Is this okay? So this is the equation of velocity. Now we are going to write the acceleration of particle executing S.H.M. So what will be the acceleration of particle which is performing simple harmonic motion? So we all know that acceleration is equals to differentiation of velocity with respect to time. Is this okay? So substitute the value here of velocity. So A is equals to d by dt of A omega cos omega t. Are you guys okay with this? Now A is equals to differentiation of A into omega is A into omega, as these are the constant terms. The differentiation of cos is minus sine omega t, and the differentiation of omega into t is written as omega. So the equation of acceleration will become minus A omega square sine omega t. Now tell me what is the equation of displacement. The equation of displacement was written as y is equals to a sine omega t. गौर से देखना है यहाँ पे, this is a, this is sine omega t, and these terms combined can be written as y. So the equation of acceleration can be written as a is equals to minus omega square into y. Is this okay? And we all know that a is equals to minus a omega square sine omega t. See, now feel the difference here. Acceleration A, this is the equation of acceleration in terms of displacement. I hope you guys are enjoying this session. Now this is the equation of acceleration in terms of time. Is this okay? Now tell me, what is the maximum value of sine theta? Plus 1, or the extreme values of sine theta? Plus minus 1. So the extreme values of acceleration. So a was written as minus a omega square sine omega t. So can we write the extreme values of sine theta? The extreme values of sine theta is plus minus 1. So the a max, or the maximum acceleration, can be written as plus minus a omega square multiplied by 1. So that can be plus minus a omega square. This is the value of maximum acceleration. Now there is a basic term which is used in simple harmonic motion, is the restoring force. What do you understand by restoring force? The force which is acting just opposite to the displacement, or in the opposite direction of displacement. So the restoring force, now we are going to write the force in S.H.M, or rather can be written as the restoring force. So what is restoring force, or the force acting in simple harmonic motion? Let us draw a diagram of a simple pendulum. This is a bob of mass m, and the bob will move to and fro like this. Now if the object will move away from, if the object is moving away from mean position, the force will act opposite to this. So if this is the direction of y, then this will be the direction of force F. So now we are going to rewrite the equation of force. So the restoring force F is equals to, we all know the second formula of second law of Newton, force is equals to mass into acceleration. So substitute the value of acceleration here. So F can be written as minus m omega square into a. So F is equals to minus m into omega square into a. Is this okay? So this is the formula of restoring force at extreme positions. ठीक है? Now this is the equation, first question. The first question is, if the displacement of a particle executing S.H.M is given by y is equals to फलाना फलाना. देखो भाई, y is equals to 0.30 sine 220 into t plus 0.64 in meter, then frequency and maximum velocity of particle is c. Can we compare this equation with y is equals to a sine omega t plus phi? So can we rewrite the value of omega? So omega is equals to 220. Now we all know the formula of time period. T is equals to 2 pi by omega. So substitute the value of omega here. So 2 pi by omega is 220. Now we all know the value of pi, 22 by 7. So 2 into 22 by 7 into 220. Is this okay? So now we are going to calculate. So this will cancel it out by 10 times. So and this will become 2 by 70, or the 2 will divide the 70 by 35 times. So this will become 1 upon 35. But the in the question we have asked frequency. So what will be the frequency? So frequency n is opposite, inversely proportional to time t. So n is equals to 1 by t. So this will become 1 upon 1 by 35. So basically the frequency will become 35 hertz. But there are two options, which is option A and option D. We can cancel out option B and option C. Now what is the maximum velocity of particle? So we can find the maximum velocity. So maximum V max is equals to A into omega. We all know the value of omega here is 220, and what is the value of A here? A is equals to 0.30. So 0.30 multiply with omega. Omega is 220. So this value will become 66 meter per second. And the option A is correct. So the correct option is option A. चलिए आगे चलते हैं. The maximum velocity and maximum acceleration of a body moving in simple harmonic oscillator are 2 meter per second and 4 meter per second square. Then angular velocity will be. So we all know the value of maximum acceleration and maximum velocity. V max is written as A into omega. So substitute the value of A omega here is 2 meter per second, and the maximum acceleration A max is equals to A into omega square, which is equals to 4. This is equation 1. This is equation 2. Now we are going to 2 divide by 1. So A omega square divided by A omega, which is equals to 4 by 2. A will be cancelled out and omega will cancel the square terms, and 2 will cancel the 4 by 2 times. So omega is equals to 2 radian per second. Yes, option D is correct here. Now let us discuss one more question. The amplitude of a particle executing simple harmonic motion with a frequency of 60 Hz is 0.01 meter. The maximum value of acceleration of particle is. Now tell me, the maximum acceleration can be written as A max is equals to A into omega square. The value of amplitude is given. A is equals to 0.01 meter. The value of n is given here, which is 60 hertz. Now, but in our equation the term omega is asked. So how will you find? We all know that omega is equals to 2 pi by t and n is 1 upon t. So this will become 2 pi n. Now substitute the value here. So we can rewrite it as 2 into pi into the value of n is 60. So this will become 120 pi. The substitute the values of A and omega. So A max is equals to A 0.01 multiplied by 120 into pi square. So 0.01 multiply with the square of 12 is 144. So 1440 into 00 into pi square, and these two decimals will cancel the two zeros. So this will become 144 pi square meter per second square. Is there any option? Yes, option A 144 meter per second square. ठीक है, okay. Now the amplitude of a harmonic oscillator is A. When velocity of particle is half of maximum velocity, then determine the position of particle. Okay, question is saying that the velocity of particle is half of maximum velocity. Guys, can you rewrite, can you tell me the value of maximum velocity? V is equals to A into omega. Now the velocity V is equals to half of maximum velocity, which means V is equals to V max by 2. So we can rewrite it as A omega by 2. Now in question, the examiner have asked us the position of particle, or rather we can say the displacement of particle. So we all know that the equation of velocity in terms of displacement can be written as V is equals to omega under root a square minus y square, and the examiner is interested in the value of y. So substitute the value of V here. So A omega by 2 is equals to omega under root A square minus y square. Now we can cancel the term here, omega and omega. Then square both the sides. So on squaring, this will become A square by 4 is equals to A square minus y square. Now transfer the y square towards the left hand side and A square by 4 towards the right hand side. So y square will become A square minus A square by 4. Now 1 minus 1 by 4 is equals to 3 by 4. So this value will become 3 A square by 4. And if we take the square root here, so y is equals to under root 3 by 2 into A. So this will be the correct answer. Y is equals to square root of 3 by 2 into A, and which is option A. Now let us discuss one more question. The displacement of a particle executing S.H.M is given by y is equals to 10 sine 60 plus pi by 3, where y is in meter and t is in second. Find the initial displacement and the velocity. See, now initial displacement and velocity, the meaning of velocity here is initial velocity. The term initial was used before and. Is this okay? So initial velocity of particle. ये एक theoretical question है. Y is equals to 10 sine 60 plus pi by 3. Now tell me, what do you understand by initial displacement? See, we have discussed earlier as well that the term initial is used when our stopwatch will just start or the time is at 0 seconds. So at t is equals to 0 second, the y will become y naught, or we can say the initial velocity. So the value of y naught is equals to 10 sine 6 into 0 plus pi by 3. Now the value of y naught is equals to 10 sine 6 into 0 will become 0 and sine pi by 3. Now substitute the value of sine 60 degree or the sine pi by 3, which is root 3 by 2. So y naught is equals to 10 into under root 3 by 2, and we can cancel out 10 by 2, which is 5. So the value of y naught is equals to 5 root 3 meter. This is the first answer. Now the examiner also have asked the initial velocity of particle. So how will you solve? The initial velocity of particle, V can be written as dy by dt. So differentiate this term d by dt of 10 sine 60 plus pi by 3. So the differentiation will be v is equals to tan into cos 6t plus pi by 3, and the differentiation of 6 into t will be 6. So we will multiply tan by 6. So we will become 60 cos 6t plus pi by 3. But the examiner have asked the initial velocity. So at time t is equals to 0 second, we will become v naught. So v naught is equals to 60 into cos 6 into 0 plus pi by 3. So the value of v naught is equals to 60 into 6 into 0 will become 0 plus pi by 3. So this will be cos pi by 3, and we all know the value of cos pi by 3. The value of cos pi by 3 is 1 by 2. So v naught is equals to 60 multiply with 1 by 2, and the answer will become 30 meter per second. So this is the answer. V naught is equals to 630 meter per second. So thank you everybody. I hope you guys have enjoyed this session, and the session will be continued tomorrow. Thank you everybody. We'll see you tomorrow. हाँ, नमस्ते भाई, सभी लोगों को नमस्ते.